All right, so let's do this section. A lot less graphing, just a lot more computation. So combining functions. So we can combine functions in the sense of you can add them, subtract them, multiply them, and divide them. And mainly what you want to pay attention here is the domain when you do that. And then we'll talk about function composition. Okay, so we'll start here. So if you add, so the domain is the intersection. So if I take two functions together, and usually we rename this as h of x. Some h of x is equal to f plus g of x, where it's the function f of x plus g of x. So the new function here. So the domain of our new function that we get by combining functions is the intersection between the two. Okay. What does that mean? That means it has the x's that we put in have to be valid for both a and b. If it's valid for a but not for b, it's not included. And so this is the same for adding, subtracting, multiplying. The only difference is here the divide functions. I have to do its domain of all the functions, and g of x cannot be 0. So so it is the intersection, plus I have to throw away everything where g of x was 0. Okay. So let's do this. Um, so we're going to take these two, and we're going to find what the function is along with all of their domains. And so here, this function is, so if I was just going to compute this, this is the square root of, so f plus g of x is equal to the function f of x, which is just square root of x plus 1 plus 1 over x to the fourth. Okay, and I will handle the domains all at the end. Okay, so we can just do it all together. Here, if I have f of x, oops, f of x plus g of x, here of, oops, let's do, I wanted to do a 3, right? It's a teeny bit sharper for me. So here I can calculate what is the square root of 3 plus 1 plus, oops, 1 over 3 minus 4. I could do this, right? And just plug in, or where I say an x, or plug in a 3. Or since I'm going to do 3 here each time, right? Since I'm going to do 3 here each time, the other option is to figure out what is f of 3. Well, f of 3 here is what? 2, right? What's g of 3? Well, g of 3 is what? 1 over 3 minus 4, so it'll be 1 over negative 1. So this is just minus 1. Okay? And so another way of saying this is I can just take 2 plus negative 1, which gives me 1. I need to leave some room for the domain. Here, we can do the same thing for the f minus g. This isn't horribly interesting, so I'll just kind of be f of x plus 1. So f of x minus f of g. And here, if we did if we wanted to find it at 3, we could plug it in, or we could use the known values. And the known values here are 2 minus the minus 1. So this will be 3. Same thing here. F of g of x is I can take f of x, x plus 1, multiply by 1 over x plus 4. So it just ends up looking like this, right? And then here, I could plug it in. I could plug 3 in here. It's a valid option. Or I can know, but since I already know what my values are, it's 2 times 1. So this is equal to 2 times negative 1. So this is minus 2. Notice if we plugged it in here, we'd get square root of 4. So 2 over negative 1. So it will give us the same answer. Let's do this one. All right, so let's do this one real quick. So here we'll have f over g of x, which is equal to the square root of x plus 1 over 1 over x minus 4. What do we do when we have compound fractions? We flip and multiply. So this will just be the square root of x plus 1 times x minus 4. Okay. And then here for the f comma over 3, this is equal to 2 over minus 1, which is equal to negative 2. All right, so let's talk about the domain. What's the domain of this function? What's the domain of f? And what's the domain of g? Can see if someone can put that in chat. What's the domain of f? Just say f's domain is blank and domain of g is blank. See if you guys can think through that real quick. Well, I only got 10 minutes. I guess I better move. Here, x plus 1 has to be greater than 0. That means x has to be strictly greater than negative 1. Because if x is negative 1, I get 0, I'm okay. Here, for g, x, so, all right, domain and domain. So here, gx cannot equal 4, right? Because everything else is fine, but if I get x equal to 4, I get a 0 on the denominator. So what's the domain overall? What's the intersection of these two? Well, where do these two intersect? That means I can start at negative 1. I can go to 4, but I cannot use 4. And so the domain is the intersection between those two. And so 4 to infinity. Basically, if you have to throw it away in 1, you have to throw it away in a position. So here, everything less than negative 1, I couldn't use, so I need to throw that away. Here for g, I have to throw away 4. Okay, so I throw away 4. And so this is the domain here. We'll go ahead and write this is the same. And also, this is the same. Okay, this has the same domain. For f here, I have to do the intersection, but does this ever equal 0? Is there any value that I can plug in for g that makes g equal 0? Can g of x equal 0? And the answer is no. And so since this one has no point where it equals 0, it's also the same here. Now you might be asking yourself a question. Why do I need to throw away 4, right? Look, when I do it right here, clearly the domain of this composition, or the combining of these two functions, I'm no longer dividing by 0, I'm multiplying by 0, so that's fine. But the answer is you really do need to throw it away if you're really doing this, okay? So it's a little bit complicated. You're going to work on some domains with the homework, so just kind of work with each other, post stuff on the things, okay? I'm going to leave this for 1 second, and then we need to get to the next one. All right, let's get to the next one. I do want to make it on. Oops, I don't need those layers. Boop, boop. All right, so let's get going. So here we're doing compositions of functions. So f composed with g. This is f composed of g, not fog. Everyone says it. F composed of g of x is f, and you plug in g of x over x. And so what we're going to do here is if I take x, I'm going to put it through, if you want to use the little machine analogy, I'm going to put it through g. That's going to give me g of x. And I'm going to take whatever g of x is, I'm going to plug it in through f, the little machine f, the function f. I'm going to get f composed of g of x. Okay, or another way for the arrow diagrams, here I'm going to take x, I'm going to act on it by g. I'm going to get g of x, and then I'm going to act on it by f, and then I'm going to get f of g of x. Okay, so that's what's happening here. So let me show you this in practice. All right, so here, so f of g of x is f of g of x. And I almost always suggest doing this, and then it'll be f, well, g of x in this case is x squared plus 3. And then everywhere I see an f, x and f, and so it'll be the square root of x squared plus 3. And you can go ahead and leave it like that. Here, if I did the other way, if I compose g of f, which is possible to do, it's g of f of x, which is equal to g. Well, f of x is the square root of x. So you just take whatever f is and you just plug it in here. And then here, you take whatever, everywhere you see an x, I'm going to plug in the square root of x. And I do it in parentheses. So here I'll have the parentheses square root of x squared plus 3. All right. Now, if I simplify this, this is just x squared plus 3. And notice that this is okay, since I'm being very clear on what I'm doing. Since the domain, I don't have to worry about saying this is, oops, this is just x plus 3. And since I don't have to worry about putting absolute value signs here, which you may have to do because the domain of this function is x is always positive. So you don't have to worry about that. Usually if you take something, you take the square root and square it, you have to put absolute value signs on it, just because you want it to have the same answer. But in this case, since the domain is negates that, it's not necessary. Okay. Can you compose a function with itself? Yes. And so here let's do g of x is equal to g of x. And when I do that, I'm going to plug in, so g of x squared plus 3. And that's going to equal hold on, my brain died. So everywhere you see an x, you're just going to plug in x squared plus 3. So here I'll have x squared plus 3 squared, because that's where I see an x. I'm going to add 3 to it. And if I calculate that out, I get x to the 4th plus 6x squared plus 9 plus 3. And if I simplify that, I get x squared plus 6x squared plus 12. And here, if we did f composed with f of x, we get f square root x, which is equal to f the square root of the square root of x, which is the same thing as x to the 4th. Okay, I'll let you write that down. And then it only gives me 4 minutes to do the last one. Anyone want to do? All right, let's do the last thing in 3 minutes. Hopefully I don't go too fast to lose you guys, but I don't want to go over. All right, so here you can do multiple combining a function. So this be f of g of h of x. And so here this be f of g of h of x in this case is x plus 3. And then here, everywhere I see that, I'm going to plug in x plus 3. So this is equal to f of g of x plus 3 would be x plus 3 squared minus 2. So we're seeing x, plug it in. And And then here, I'll simplify that before moving forward. So it'll be x squared plus 6x plus 7. That's just doing the math. And then here, 1 over x. So this is equal to 1 over x squared plus 6x plus 7. All right. And then here we go. So here, if I wanted to do this composition of a half, what I would do is I'd kind of work it backwards. So f of g of f of a half. Instead of actually computing this all out, what I do is just find what's f of a half. Well, f of a half, 1 over 1 over 1 over 1 over 2 is just 2, right? So that's just equal to h of g. So f of a half evaluates to be 2, so I just plug in 2. Well, what's g of 2 evaluate to be? Well, g of 2 is 2 squared minus 2, so that evaluates to be 2. So h of 2, because g of 2 evaluates to be 2, and h of 2 evaluates to be 5. Okay. All right. And since we're out of time, we'll go ahead and skip the word problem. It takes about, I don't know, it takes about like 5 minutes to go through. So we'll go ahead and skip it for the day. That way I can get you out on time. All right, guys. Phew. Sure, we can talk after class. All right, yeah, so go ahead and skip the word problem. It's actually, it's a really fancy way of making something real funny. Is you just have a little lighthouse right here, and some ship passes it 4 miles from shore. And you want to know what's the distance between the lighthouse and the ship when the ship travels at 50 miles per hour? Well, the distance the ship travels is 15 miles. And then you just make, and so the distance here is equal to, so this s is equal to the square root of 4 squared plus that d squared. Well, I know what d squared is, and so so s of t just ends up being, you just plug in s composed with d of t. So you get s of t is equal to 4 plus 15 t squared. So that's how it goes down if you were curious. Okay. All right, guys.